Thank you everyone for joining us for this webinar. My name is Laura Lawrence and I'm the Global Marketing Director at Harman. And now I'd like to introduce you to Andy Coules, the presenter for today's webinar. Andy is a sound engineer who tours the world with a diverse array of acts in a wide range of musical genres. He also writes articles for various print magazines and created a live sound course that he's taught in London, Hong Kong, and Algeria. And now I'll pass it over to you, Andy.
Okay, thank you for the introduction, Laura. Today we're going to look at the history of live sound, which is a subject that has always fascinated me because it's a story of kind of inventors and pioneers who have created and combined various bits of technology, often which is intended for other purposes, to help us share music to a larger audience and at a much better quality. And that's helped us to make the whole sort of live music a much more enjoyable communal experience. It's also very much a sort of evolutionary process. And it helps us kind of understand how we got to where we are now, how we've evolved the way we do live sound, because people tried out new ideas or bizarre techniques and they became copied, and other people, it became the norm. So that's why I'm interested in this subject generally. But we're going to start by taking a dive back in time and trying to find the roots of live performance sound. So if we just dive back to 20 BC, the earliest example I can find of anyone actually trying to create a space that's conducive to live performance was a Roman soldier, architect and engineer called Vitruvius, who wrote a book called the Architectura, which was the first kind of known example of architectural acoustics. He wrote at length about using these copper vases to create a better environment acoustically in enclosed theatres. We don't really know if they worked because none of them actually survived, but the principles he established were then taken up by the Greeks and the Romans in the building of their amphitheatres, which you can see pictured here. This is typically a semicircular tiered seating area which focuses the attention down onto the performance area. And in so doing, it provides excellent sight lines as well as good audio lines so people can hear more clearly. But this is more sort of acoustics. It's not quite relevant to the sound system and live sound as such. So I'm going to jump forward to the era of classical music. So this is quite an interesting period in music because a lot of the music that was written at the time was actually written to be performed in a very specific environment. If you take the example of church or choral music, it was very slow-moving, majestic music that was designed for the large reverberant spaces that churches were. Likewise, symphonic music was also quite grand and stately because it was designed to be played in large concert halls. By contrast, chamber music, which is pictured here, is actually quite quick and jaunty. It's fast-moving. The bass lines tend to move quicker because the acoustics of the environment allow that to happen, but also because it was typically used for entertainment and for dancing. But again, there's no real sound system at work here, nothing that we can really trace to what we think of as live sound in the modern era. But interestingly enough, mixing did happen in terms of if you wanted to turn up the violins, you added more violins to your group. And that's kind of how the orchestra evolved. It was the size of the different sections were there to amplify those instruments specifically to be heard in the right balance. But talking of musical acoustics, Richard Wagner, well known for his ring cycle and his massive dramatic operas, the German composer, he actually went a step further and built an opera house called the Bayreuth Festival Theatre, specifically to flatter his own music. And to this very day, the only music that's allowed to be performed there is the music of Richard Wagner. So, yes, so we've established acoustics in performance. But moving forward, we really needed to get to the age of electricity to really see the birth of what we think of as a modern sound system and live sound. And for that to happen, we need to have the building blocks of a sound system. Someone needs to invent them. So I've identified what I believe to be the three key components of a sound system. And they are, of course, a device to capture the sound vibrations and convert them into electrical signals, Then we need some kind of device, way of increasing the amplitude or the volume of these electrical signals. And then we need a device which converts the signals back into sound vibrations and propagates them into the world. So of course what we're looking for to be invented is the microphone, the amplifier, and the loudspeaker. And as I say, these three components are core to all sound systems that pretty much have ever existed. Now the first thing to be invented of these three was the microphone. And as is usual with a lot of these inventions, there's a lot of parallel development going on, people doing similar things at similar times, and it's not always clear exactly who did it first. Oftentimes the person who got the patent wasn't necessarily the person who actually did it first. And when it comes to the microphone, this is no different. The earliest example I can find is kind of Philipp Reis, who's a German inventor, in 1861 had a very rudimentary microphone on his prototype telephone. But this wasn't really kind of microphone by modern standards or modern definitions. If you want to get to the actual true first proper microphone, which can be considered to be the first of its kind, you've got to look at the carbon microphone, which came along shortly afterwards. It's much more robust, and it much more works in a similar way to which most microphones have since. And as you can see from the images, there are three people who are often identified as creating the microphone first, depending on who you ask. Emil Berliner, David Edward Hughes, and Thomas Edison. But most historians agree, I think, that it was David Edward Hughes who first demonstrated his carbon microphone in 1875. Interestingly enough, he never sought patent for his invention because he wanted it to be a gift to mankind. But crucially, I think he was the first person to actually call it a microphone. And he took his inspiration from the word that was in existence, but it was basically believed to mean the audio equivalent of a microscope, because a microscope got small images and made them larger. The microphone would take small sounds and make those larger. So that's how we get the name, and he was the first person really to use that. So here we've got a diagram of that very first microphone. It's interesting just to study how simple it was, but how brilliant it was. And I'll just take you through the individual components here. Here we've got highlighted in red a carbon rod, just a rod of graphite, which is loosely held between two carbon cups, which are then connected to a circuit featuring a battery. Now there's two wires trailing off, would go off typically to what was considered a rudimentary version of a loudspeaker, or what was often called an auditory tube, so you can actually hear the signal. Now how it worked is now being demonstrated. The vibrations would hit the rod and make it vibrate. It would rattle very slightly inside those carbon cups, and as a result the resistance across it would fluctuate, which of course alter the current, which means you now got an electrical signal which is analogous to the original vibrations that triggered the system. So you've done the transduction. Transducing is the act of converting energy from one form to another, which is exactly what microphones and loudspeakers do. So this, even though it's quite a basic idea of having this rod rattling around in these cups, it was actually surprisingly sensitive. They claimed that they could detect the sound of a fly walking next to the microphone. But the design was then refined by them and other people. The carbon granules were compressed between two metal plates and used in a very similar way, and used in the early telephone, which is probably the very first application of the microphone. And even though the carbon microphone was superseded by superior designs such as the dynamic, the condenser, the ribbon microphone, it was still in use in telephony up until the very late 20th century, interestingly enough. So the next invention we need, or that happened, is the loudspeaker. As I said before, various loudspeaker-like devices existed in the 1870s and 1880s, most notably on Alexander Graham Bell's telephone in 1876 and Thomas Edison's phonograph in 1877. But Oliver Lodge, pictured here in that's not a picture from 1898, but in 1898, he developed the very first moving coil loudspeaker, which is the forebear of all speakers since. Again, it's very much exactly the same design that is in use nowadays. It would have looked a bit like this. I couldn't find a picture of the actual invention, but this is the closest thing there is. Essentially a driver feeding into a tube that would expand the sound and make it louder. I've got a better diagram which shows you what's going on if you've never understood how a speaker works. Essentially, you've got this moving coil which is wrapped around a magnet. They're not touching the magnet, it's attached to the cone. And as you apply your signal to it, the voltage goes up and down, and that then attracts some repulsors from the magnet, causing the cone to move backwards and forwards, and moves the air, of course, which produces vibrations, so it converts the electrical signal back into vibrations or sound. And it's such a brilliant and simple device, and as I say, it's still in use today. It's still the fundamental design of all loudspeakers. Pretty much whatever you're listening to me on right now has the same stuff going on inside, a moving coil, a magnet, and a cone. So it really was a brilliant invention of its time. Obviously, speakers have improved over the years, better magnets, better cones, better enclosures, but that's fundamentally the same thing that Oliver Lodge originated back at the very end of the 19th century. So now we've got our microphone and our loudspeaker. The thing we need, of course, is an amplifier. So we had to wait a few years for this, but in 1906, Leader Forrest created the Audion, which was the first ever device capable of amplifying an electrical signal. And what he did was he took a 2-electrode diode. Actually, I've got a picture of it here. This is the Audion. He took a 2-electrode diode and added a 3rd electrode called a control grid. And what he found is as he fed a small current into the control grid, it controlled a much larger current going across the other 2 electrodes, the anode and the cathode, thus creating a power gain. So as I say, it was the first device ever capable of amplifying an electrical signal. This, of course, became the vacuum tube, or the valve, as various people know it, which was used extensively in radio, in telephony, in TV, and, of course, the early computers. Okay, so just let me take a sip of water. So now we have the microphone, the amplifier, and the loudspeaker. Various people set about combining them to create various sound systems. 2 notable pioneers pictured here are Edwin Prism and Peter Jensen, who set up a laboratory in Napa, California in the 1910s. They used it to experiment on various things: telephony, electronics, loudspeakers. And one of their very earliest experiments is documented as they set up a microphone, a loudspeaker, and connected them to a 12-volt battery. And the first thing they heard was a loud, deafening crack, which they compared to the sound of a gun firing, and followed by a deafening scream. They couldn't turn it off quick enough. Now, obviously, what happened was feedback, and this was not something unknown to people in telephony. It was often referred to as howling, but it's definitely something we've been dealing with ever since. And it's always typically caused by putting the microphone too close to the speaker. So they came up with the simple idea of mounting the loudspeaker on top of their roof of their lab, and conducted tests and were able to hear the voice up to 7 miles away, which is quite impressive for its time. Now, putting this into context, we take for granted the amplified voice in today's world. We hear it everywhere in public spaces, for safety announcements, for information. But in the very early 20th century, not so much. It wasn't a very common thing at all. It didn't really exist. It was a very new thing. So there's some great stories about Pridham and Jensen testing their system in their valley, and the local townsfolk thinking that someone was standing outside their door talking to them. And they go outside into their garden and look around and try and find who this person was, because they couldn't comprehend that someone talking to them couldn't be within eyeshot, couldn't be within sight. But apparently they were quite liked in their town, because they did regular listening parties where they play records for the whole town of the music of the time. Now what they did is they went on to form a company called Magnavox, which is Latin for great voice. And Magnavox was the name they'd given to their loudspeaker. And they thought it was a great name for the device itself. And they actually anguished over copyrighting the name as their company name, because they thought it would be a great name for everyone to call speakers Magnavoxes. And they actually felt quite guilty later on when the word loudspeaker became commonly used in about 1920 because they thought their word was better, but they'd already made their choice. So the reason I'm focusing on these two guys is because they took part in what is pretty much a very significant event in the history of live sound, which happened in 1915. Now, in San Francisco, the Bulletin newspaper would put on a regular Christmas Eve event in town for the townsfolk, which would involve the performing of Christmas carols and usually a guest singer to perform for the audience. Normally they held it at Lotta's Fountain, but in 1915 they decided to move it outside the front of the newly completed Civic Center, which had a large open plaza. You can see it in construction in this image. They invited Magnavox along to test out their sound system, and they heavily promoted the event. They promised the sound miracle and the fact that people would be able to hear the performance from very far away. So as a result, a crowd of 100,000 people turned up, and this is an actual picture of that crowd taken on that night. At that time, that was pretty much about an eighth of the population of the whole of San Francisco were there. The event was deemed a massive success. The newspapers the following day declared that with their horns concealed behind American flags, the sound seemed to issue from the granite side of the building itself, and that the entire audience heard carols and speech with absolute distinctness. So this, of course, was the first ever amplified musical performance. And more importantly, it showed what sound systems could do and how they could be used in addressing the public. And this carried on in the following years. Various companies such as Marconi, Tannoy, Western Electric, and Altec all got involved, often developing technology hand in hand with the fields of radio, telephony, and cinema. But there were certain key events that showcased just what a sound system could do and spread their popularity amongst people and event organizers. One of those was in 1919, when Woodrow Wilson was the first sitting US president to ever use a sound system. He actually used the Magnavox system in San Diego to a sports stadium full of about 50,000 people as part of his promotional tour for the establishment of the League of Nations, which is the organization which went on to become the UN. And you can see from this front page of the newspaper that it went down very well with the crowd. If we hop across the Atlantic to England in 1924, King George V opened the actual British Empire exhibition at Wembley using a Marconi sound system and spoke to an audience of 90,000 people. This is also has a distinction of being the first ever recording in the United Kingdom. And if you search for it, you'll find it on YouTube. It's fascinating to listen to because you can actually hear little bits of feedback, which always makes me cringe as a live sound engineer. So these are all examples of obviously public address, which is of course where we get PA from when we talk about our PA systems. It shows us the root of sound systems, which is pretty much in amplifying the human voice. And musical applications came along later. Now, as we move on from this time into the 30s, we find that sound systems were used in music to a limited degree. They were often used to amplify the human voice to make it loud to be heard over the band, but little else. Part of the problem here was the limitations of valves or vacuum tubes. They ran very hot, they're power hungry, so it's very hard to build big amps because they would just literally get too hot and potentially melt. Here's an example of an advert I found for an amplifier of the time, a 45-watt master amplifier. You probably wouldn't have got much more wattage at that time because you physically couldn't build them any bigger. So there was a big push to get more efficient form of amplification than valves. And this was often pushed by the telephone companies because the telephone companies had a bigger interest because one of their biggest issues in the early days of the telephone and telegraphy was signal loss over distance. And anyone who's ever run an audio system knows that if you run electrical signals through cables, there is resistance, you'll lose signal. It'll always come out the other end less than it went in. And the longer the run, obviously, the more loss of signal. So this was a really big issue for phone companies. But towards the end of the 1940s, certain advances in semiconductors were starting to point the way to a potential solution, and it took 3 guys at Bell Labs in 1947 to make the breakthrough. And here they are. This is a picture from left to right, John Bardeen, William Shockley, and Walter Brattain. What they did was really simple but quite brilliant. They took a strip of gold foil, sliced it in 2 with a razor blade, and attached it to a wedge of plastic. They then pushed it right up against a chunk of germanium. And what they ended up with was the very first transistor, which is pictured here. This is the actual first one they made, which can be seen on display in the Smithsonian Institute. Much like the vacuum tube, it had 3 terminals, the germanium obviously, and the 2 pieces of gold foil which did not touch. They were both in contact with the germanium. And what happened is that when you applied a small current to the germanium, it changed its conducting properties so that a larger current could be allowed to flow between the 2 pieces of gold foil. And of course, you get a power gain from that. So shortly afterwards, they replaced the germanium with silicon. They refined the design, and they won a Nobel Prize for it in 1956. William Shockley even went on to found Silicon Valley in California. Because of course the transistor was brilliant for computers because it's fundamentally a switch. When you've got a switch, you've got on, you've got off, that's a 0 or 1, there you've got a computer. But of course the transistor was brilliant for audio as well because it allowed us to build much smaller amplifiers that ran much cooler, which could have then been much more powerful. So as we go into the 1950s, things start to get really interesting. The electric guitar is invented, which has a knock-on effect of causing the very limited PAs, those limited systems of the time, to be pushed into distortion often, which caused quite a raucous sound, which of course typified rock and roll, which was becoming very popular at this time. It even pushed some manufacturers to declare that their warranties were void if their systems were run at full power, and some of them even threatened to cut off retailers who sold their equipment to bands who performed what they called the music of the devil, which was, of course, rock and roll. As we go into the 1960s, bands would typically own their own sound systems and carry them with them, the smaller bands, because the venues were typically theatres, ballrooms, or halls, places that were designed for other purposes. So they bring their own systems along, and of course the Roadie was born. This is a great story I heard about bands in that period would set up their sound systems. The headline act would set up their sound system, and then the support acts would come and set their sound systems up in front of the headline sound system. And after they played, they'd remove their systems, so they'd peel back these layers of sound system. And typically the sound would get better as you went on because the headliners would be able to afford a much better sound system. When it came to festivals, they would pool their resources. They put all their speakers and amps together and make some big Frankenstein kind of sound system for everyone to use. So moving on now, I just want to take a sip of water. So here we have the Beatles at Shea Stadium in 1965. The Beatles obviously were a very popular band at the time. They played the Ed Sullivan Show in February of 1964 to an audience of 75 million, a TV audience of 75 million. So their popularity was big, particularly in America. So they were looking to play bigger and bigger places. So this event, as pointed out, is very much a watershed moment for live sound because it's pretty much the first stadium show. They booked it and sold tickets to 55,000 people. And as you can see from this image, it's quite a nice side image. The audience were actually tiered in 3 tiers and actually in a semicircular arrangement, not unlike the amphitheaters that we looked at earlier on. But they were quite far from the band, and quite a lot of them, as you can imagine. Various acts played that day. Ed Sullivan came up and introduced the Beatles, who of course the headline act. They got up and played 12 songs in 34 minutes. Now, if we just take a look at an aerial shot, which I've taken from the film, you can see what was going on here. The stage here is quite far into the field. The band only had 100-watt amplifiers for their guitars, which weren't run for the sound system, so they weren't going to carry very far. And you can actually see the sound system. It's this ring here of speakers ringed all around the performance area. And if we look at this other image here, you can see that you can see the speakers behind the band as they walk on stage. These were 6-foot column speakers, quite formidable, I guess, for their time. But as you can probably guess, it probably didn't make its way very far. The sound, it probably didn't make its way very far into the crowd. It certainly wouldn't have made it very far up into the crowd. And of course, the sound was terrible. The audience couldn't really hear the band due to the screaming that was prevalent at the time. The band couldn't really hear themselves. John is heard to comment and actually asked the audience, "Can you hear us?" at various points during the performance. It was filmed. I've seen the whole film of it. You can find it. It was recently remastered, I believe. And interestingly, I think the recording from the live gig was so bad, because the sound system was so bad, that they pretty much overdubbed the whole thing, even to the extent where one song called Act Naturally was, they used a studio recording, which was quite interesting, because you hear this acoustic guitar and you're looking around the stage and you can't actually see an acoustic guitar, but I guess that worked for the time. It's no coincidence that a year later, pretty much a year later, the Beatles stopped touring altogether. They just decided it wasn't a worthwhile or rewarding experience, partly because of the sound systems, partly because of the touring, but definitely sound systems would have a big effect on that decision. And the next thing they did, of course, was Sgt Peppers Lonely Hearts Club Band, which a lot of people think is their idea of creating a band or a record that would be a band that would go out and tour in their stead, because they, of course, no longer wanted to do it. So that almost brings us to the end of my presentation, but I just want to say this was pretty much a classic example of the sound industry trying to run before it could walk. It's often been said that modern touring and the sound industries were born the day after that concert. But the truth is there were many pioneers working away after and before that to build new and better sound systems, often demanded by bands to push further what technology could do at the time. But that, of course, is another story which I will tell you in part 2 of this presentation, which will be on Friday. So yeah, please sign up for that and come along and enjoy that. But before I leave, let's see if there are any questions.
There are. All right. The first one is asking, sorry. Here. What caused the loud crash in Freddie and Jensen's discovery of feedback?
Sorry, can you say that again?
Yes. What caused the loud crack in Freddie and Jensen's discovery of feedback?
I'm assuming that's the voltage being applied to the speaker. It would have made the cone just instantly move rapidly against the magnet, which would have just gone thwack.
Okay. There haven't been any other questions that came in. Well, what can you tell us about the WEM system?
Sorry, I'm having difficulty hearing you.
What can you tell us about the WEM system?
That's we're going to go into that in great detail in part 2.
Okay. The next question is asking how far you'll cover the live sound history in part 2.
Yeah, well, pretty much from that concert onwards to now, to what we're doing now, to the practices and the systems that we're currently using in live sound all around the world. So I'll bring it right up to date.
Okay. If anybody else has a question, just put it into the chat, and Andy will be happy to answer that. Give it a second here. This next question, I'm not sure if I'm understanding it. It says, would you involve some records? We might need clarification on that one. Okay, we have a question asking, will you be talking about other early Frankenstein PAs, like what was at Woodstock?
Oh yeah, definitely. I'm going to focus on, as mentioned before, Wham, which is Charlie Watkins' company, but also going to be looking at Bill Hanley's legacy, which of course the thing he's most famous for is the system he built at Woodstock and the Fillmore East. So we'll be going into detail in his innovations on Friday.
All right, next question is asking, do you know who set up the Shea Stadium system for the Beatles concert?
Sorry, did I help with that? Is that the question?
It's asking if you know who set it up.
Interestingly enough, I've tried to do some research on that and no one's really come forward. They did play Shea Stadium in 1966 and Bill Hanley did the sound system in that occasion, but no one of any note was used for the 1965 concert, and from what I'm reading between the lines, because it was such a terrible sound, no one's really taken credit for it, so it's difficult to say who actually did it on the day.
All right, next question is asking, is there a correlation between recorded sound and live sound in terms of its outcomes?
I think, yeah, both have always operated hand in hand. Certain innovations have been passed from one to the other. The mixing desk obviously was used in recording studios before they were used in live sound, and obviously technology for monitor speakers and microphones is crisscrossed between the two. So they've always been sort of brothers, I guess, in terms of technology.
Next question is asking, will the wall of sound be on part 2?
Sorry, with what sound?
The wall of sound?
Not in any great detail, no. The wall of sound you're referring to is, of course, the Grateful Dead sound system, which was a massive wall of speakers they built behind them. And the idea being that the band would pretty much hear what the audience heard, but they only actually used it for about 1 year. I think it was 1974, before they abandoned the idea. It was a nice idea, but it didn't really have legs. And I think in terms of the evolution of sound systems, it was pretty much a dead end, albeit a great idea that didn't quite work at the time.
Okay, the next question is asking if a recording of the webinar will be available. Yes, it will be. All of the webinars are recorded, and we send them out several days after the live presentation, as well as listing them out to our YouTube channel. It looks like that was the last question that came in. So Andy, thank you so much for the presentation, and thank you everyone who attended. If you're interested in learning about future sessions, you can check that out on crew.harman.com and see the full list and calendar. And we hope to see you back for part 2. Thanks very much. Have a great day.
Bye.